All right, two assignments regarding the remainder theorem. Here's the first one. It says find the value of c so that x plus 1 is a factor of the polynomial p of x. All right, here's what this means. The remainder theorem says if we use the 0 of this factor, the 0. Now, a 0 of a factor is merely saying what would you do, what would you plug in for x so that you end up with 0? So in this case, we see it says x plus 1. That means what we're going to do is we're going to examine what happens if we plug in -1 everywhere into the function. That's what the remainder theorem says. Remainder theorem says you can find the remainder if you divide by a factor like x plus 1 by plugging in the 0. So we're going to plug in -1. Here's the other part to this. It says find the value of c so that x plus 1 is a factor of the polynomial. If something is a factor, that means the remainder equals 0. So what we're going to do is we're going to plug in -1 into all of this. Each x, we're going to plug in -1. Make sure you use parentheses around that -1. Also, we need to remember our order of operations here. So when I'm typing in, -2 times -1 squared, or 7 times -1 to the third, I have to do exponents first. So we have this giant long equation, and then plus c. What we're going to do is set it equal to 0. We're going to say equal 0 because it says, how would you make it all a factor? It's a factor when the remainder is 0. What we're going to do is we're going to figure out what is all of this plus c equals 0, and then we're going to solve for c. All right, so if we do all that, -1 to the fourth we have to do first. That's 1. 5 times 1 is 5. Right? -1 to the third we have to do first. That's -1. 7 times -1 is -7. -1 squared has to be done first. We have to do exponents before we multiply. 1 times 2 is 2. There's a minus. This is plus 3. Plus c equals 0. And then we're going to solve. All right, so we got 5 minus 7. That's -2. Minus 2, that's -4. -4 plus 3 is -1. Plus c equals 0. Well, that means our answer is going to be +1. It's just kind of a coincidence on this question that we ended up with 1 and there's a 1 there. That is not always the case. All right. So that's remainder theorem and factors. Remainder theorem practice is the same type of assignment. It's actually a lot faster, right? So what is the remainder? Well, we can find the remainder by plugging in the opposite of this. Remember, on the previous assignment, what we were doing was we were saying, what does c have to be in the equation so that we end up with a remainder of 0? On this one, we're going to plug in 2. We're going to say x equals 2. Plug it into each and every x in the equation. Make sure you do exponents first. So first one, 2 times 2 to the fourth. 2 to the fourth first, that's 16 times 2 is 32. 2 to the third, I like to use parentheses around that, that's 8. Plus 2 times 2 squared, well, that's actually the same as 2 to the third. There's 3 2's there. So that's also 8. And this is minus 6 at the end. So we end up with 26 here once we compute all that. And that's our remainder. That's the remainder theorem. Super awesome.